statement based on the text-based statement obtained in the last chapter. Okay. The goal of domain analysis is devising a precise, concise, understandable, and correct model of the real world. How to build? Usually, we need to interview the business experts, examine requirement statements, and scrutinize artifacts. And domain models only focus on what must be done rather than how it is done. It means that in the domain analysis stage, we only focus on what need to be done rather than how to do. In the system conception chapter, it means in the last chapter, we have the output of the system conception is a problem statement. It means that we do it with users, developers, and managers. We generate some requests and then ask several questions about the system idea, and at last we get some text-based problem statement to describe the system briefly. But we know that this natural language-based statement is incomplete, informal, sometimes ambiguous or inconsistent. And then in this chapter, we will build models. And these models may include class models, state model, interaction models. And it is called the domain analysis and the application analysis. It means based on these two analyses, we will get several models. But how to build models? It means we get models by user interview, domain knowledge, real-world experience, and related systems. And usually the models built or established during the analysis stage is precise, concise, and rigorous. It is different with the text-based or natural language-based statement. It means that the main goal of analyze is changing the text-based statement into precise models. So the process of constructing a rigorous model of the problem domain forces the developer to confront misunderstanding early in the development process while they are still easy to correct. It means that when we are building these precise models, we may find some problems or find some flaws in the flaws earlier. It means that found problems or found errors before implementing it. If we found the problem of flaws after we have implemented the software, it will be costly to correct the mistake. So the analyze model usually addresses three aspects of objects. They are static structure of objects using class model, and use interaction models to describe interactions among objects, and life cycle history of objects using state models. It means that in the analyze stage, it means in the domain analyze stage, we need all three kinds of models we have studied. Analysis is not a mechanical process, but it is a matter of art. Why it is a matter of art? Because most problem statements lack essential information. It means that these problem statements means the text-based statement obtained in the system conception stage. And this information is like essential information which must be obtained from the requester or from the analyzed knowledge of the real-world problem domain. But the output model depends on analyst or requester's knowledge. It means that different person may generate or means different person may build different models because they have different background knowledge and so on. And there's a choice in the level of abstraction for the model different. It means different experts might use different levels of abstraction because sometimes we have multiple choice, but all of them works. So it depends the models. We can't say which one is correct or which one is error. And for the analysis, we usually divide the analysis into two substages. The first one is called the domain analysis, and the second is application analysis. In the domain analysis, we are understanding the real-world essence of a problem. For example, if we want to develop an online tax hailing system, in the domain analysis stage, we will focus on the cars, drivers, and customers. They have real-world counterpart. But in the application analysis, we will focus on that application artifacts that are seen by users, for example, the app components of graphical user interface. So, in different substages, we focus on different objects. In this chapter, we will mainly focus on the domain class model. The first step in analyzing the requirement is to construct a domain class model. We know that class model describe real-world classes and their relationships to each other. So information for the domain model comes from problem description, from system conception, expert knowledge, and general knowledge of the real world. This is the three sources of domain model. So the stage of building domain class model is, so first we should find appropriate classes, then prepare a dictionary to describe each classes. Then we need to find associations among these classes and add attributes to classes. Then organize and simplify classes using inheritance. It means organize the classes into different layers and verify access paths exist for likely queries. It means check to verify whether the class is correct and iterate and refine the model. Then the last two are reconsider the level of abstraction and group classes into packages. Usually, in the domain analysis stage, we don't focus on the operations. And so let's see, the first stage is finding classes. At first, we should find relevant classes for objects from the application domain. And so before that, we should understand what is object. Objects include physical entities such as houses, persons, and machines, as well as some concepts such as trajectories, seating assignments, and payment schedules. It means not only the physical, but also the concepts are objects. And all classes must make sense in the application domain. And we should avoid computer implementation constructs. Don't focus on the computer implementation. So how to find classes? First, we should list our candidate classes found in the written description of the problem. Because in the system conception stage, we have got some text-based statement. They are obtained by interview some experts and discuss with the requesters or customers. And we have read some text-based description. So At first, we should find some classes from this source. You don't be too selective. Just write down every class that comes to mind, and we can select appropriate classes later. So classes often correspond to nouns. So at first, we should focus on the nouns in the statement. For example, in the statement, a reservation system to sell tickets to performances at various theaters. If we see this kind of statement, the tentative class would be reservation system, tickets, performance, and theater. Because all of them are nouns, it means from the requirement source, we can abstract nouns to get some tentative classes. And then we need to eliminate some spurious classes. So don't worry much about inheritance or high-level classes. It means at the beginning, we just first get some specific classes right, so that you don't subconsciously suppress some detail in an attempt to fit a preconceived structure. For example, if you are building a cataloging or checkout system for library, identify different kinds of materials such as books, magazines, newspaper, record, video, and so on. It means you can first write down books, magazine, newspaper, records, and videos first, without caring much about how to categorize them. Then after that, you can organize them into broader categories later by looking for similarity or differences. It means at first you can just write down all of them, and then after that you can looking for similarity to abstract into different groups. Okay, this is a case study for the ATM. We have found some tentative class. These are from tentative class found from the text statement in the last chapter, obtained in the system conception state, and we can see that there are software, banking network, cashier, ATM, consortium, bank, banking, computer account. It means that most of the nouns are read down here. And in the figure 12.4, it is some classes. These classes are not obtained from the text-based statement directly, but they are from the knowledge of problem domain. But after that, we should eliminate some classes. It means that we should keep the red classes. Here are some criteria to discard unnecessary or incorrect classes. The first is we should remove redundant classes. If two classes express the same concept, you should keep the most descriptive name. It means, for example, here, the first one, here based on ATM example, it is redundant. User is redundant. Why? Because we have customers. We have already write down customer, and user can be considered to be redundant because customer can describe is more exact, can describe the person who use the system more exactly. It means the customer is more descriptive. The second is remove irrelevant class. If a class has little or nothing to do with the problem, we can send irrelevant. It means the cost is meaningless, irrelevant with this system. And remove weight classes. You define boundary out to be too broad in scope. Weight system is too broad. No meanings in this system. Because the system means the whole system. It cannot describe some specific objects. And the security provision is and record keeping provision all don't have some clear boundary about what kind of objects to describe. Banking network. It is also too large. The network may include the bank computer, ATM are all in the network. So the boundary is too large. And remove attributes. We can see that account date belongs to, it is an attribute of account, and cash is also maybe an attribute of cash card, or receipt is a transaction date, some attributes of transaction. So they should be attributes. It means that, for example, some names primarily describe individual objects should be restated as attributes. For example, name, birthday, and weight for a person. They cannot be considered to be classes. They are only attributes. Remove operations. If a name describes an operation that is applied to objects and not manipulated in its own. It means that usually we shouldn't include operations in a system as class. For example, phone call in the phone system is an action associated with call and network. But sometimes an operation may have meanings and in itself, so it can be considered to be a class. For example, in the billing system, the call is a class with attributes date, time, origin, and destination. So it depends. The third is remove roles. Name shouldn't be the role that it plays in a system. For example, the owner is a kind of role, so it is not a good class. For example, in a system for managing cars, for example, the online tax hailing system, maybe initially the system want to include this information of who owns the car or owns the taxi. But in the future, maybe the system is extended to include the scenario that the car is not owned by someone, but it is only borrowed by someone it means some cars borrowed by someone can also and it can also be managed by this system. So the owner is not appropriate now. And remove implementation constructs. For example, the process, algorithm, this kind of names are implementation details, not classes. And remove derived class. It means that we usually omit class that can be derived from other classes. These are implementation. Access, software, communication line, transaction log, all of them are implementation, so they should be removed